A torque wrench is a tool used to apply a specific torque to a fastener, such as a nut. A particular torque wrench has a length of 30 centimeters. So torque wrenches are used in manufacturing when you need to, tighten a nut or bolt to a particular torque in order for it to be safe or operate as intended. It's also used in the automotive industry. So if you've ever changed a tire, you might have a tire with lug nuts on it, and that's in the boot of your car. You might have a wrench that's like extra long, and that's to help you tighten it to the certain requirement. So for each of these scenarios, calculate the torque, including the direction. So, question 1A, part 1. Let's go. So let's draw the pivot point, and here's our wrench, and we are applying a force of 20 newtons upwards at a distance of 30 centimeters. So 20 newtons up at a distance of 30 centimeters, like that. If you drew it this way, you're not wrong, right? Because that is a distance of 20 newtons up, 30 centimeters from the pivot point. The question didn't tell you whether it's on the right or the left, so either one works. So to calculate torque, denoted by tau, T-A-U, torque is the force applied times the distance from the pivot point. And the key feature here is that the force is perpendicular, so 90 degrees, to that displacement, to that distance. Right, so in this case, I've drawn it so that they are perpendicular. In other cases, it might be on an angle, in which case we'd need to work out a component. But here, it is as simple as force, 20 newtons, times distance. Being mindful, we need SI units, so that's 0.3. So calculating that, 20 times 0.3 gives exactly 6. And now what are the units? Well, force, newtons, distance, meters, so torque would be in Newton meters. You might have heard of pound-foot of torque before, so that's those pesky Americans. I can say that because I'm half American, right? But in SI units, it's Newton meters. Part 2, a force of 40 newtons upwards at a distance of 15 centimeters. So let's do the same arrangement. So here is our wrench, but we're applying the force of 40 newtons at a distance 15 centimeters from the pivot point. So like before, torque is force times distance, all in SI units. 40 times 0.15 also gives 6 Newton meters. So why is that? Well, we doubled the force, but we halved the distance. And since the equation for torque is force times distance, doubling and halving, they cancel out, and we're left with the same magnitude for torque. And actually on that, I've forgotten something. It did ask us to specify the direction. So looking back at part 1, how will this rotate? So if we're applying a force up, it's going to turn the wrench anti-clockwise. Right, it's going to rotate the bolt or the nut anti-clockwise. So that's our magnitude, and we could do an arrow going like that to show the direction, or we could write counterclockwise, anti-clockwise. Yeah, any of those work. And similarly for part 2, it is also counterclockwise. Part 3. Whoa, a force of, 10,000 newtons upwards at a distance of 0 centimeters from the pivot point. So we have our pivot point, 10,000 newtons up, and here's our wrench, but we're not applying the force anywhere on the wrench, we're actually applying it exactly at the pivot point, which is why the distance from the pivot point is 0 centimeters. So you could think of this as you're literally just pushing upwards on the nut. But we can still work out the torque, force times distance, right? The force being 10,000 newtons times the distance of 0 centimeters gives us exactly 0 newton meters of torque. So what does that mean? It means we're not applying any rotational force. All as we're doing is applying a translational force, right? We're trying to move it up, which may damage the ball. What would the direction be? Well, if the magnitude is 0, the direction doesn't matter. In fact, it doesn't make sense in this situation. And part 4, a force of 100 newtons upwards at 10 centimeters and a force of 10 newtons downwards at 25 centimeters. So let's sketch that. Here's our pivot point, here's our wrench, a little bit wonky, but it is how it is. 100 newtons at 10 centimeters. And 10 newtons down at 25 centimeters. So you could think of this as you're now using two hands. One is mostly being pushed up, but then your other hand may be resting on it and it's resisting it a bit with 10 newtons. To find the combined torque, we will need to find the individual torques from each force and then add them together. Being mindful, we subtract opposite directions. So let's work out, let's call this tau 1 and tau 2. So tau 1, or the torque at position 1, is its force, 100, times its distance in meters, 0.1, which would give 10 Newton meters. And now what would that direction be? Right, following the arrow around, it is counterclockwise. Now looking at the second torque, lower force of 10, but a greater distance of 0.25 meters to give 2.5 Newton meters. The direction following the arrow around would be clockwise. And so the total torque would be, oh, just realized you can't see my direction. Sorry, there we go. So torque 1 was anti-clockwise, torque 2 was clockwise. To find the combined torque, we need to define which way is positive first. So I will go counterclockwise is positive. Right, that's my coordinate frame. Right, I've defined which direction is positive, which means this torque is positive, however this one must be negative. So let me just add that in there, because they're acting against each other. So the total torque is 10 minus 2.5, which is 7.5 Newton meters. And since that is a positive number, we know that it's acting counterclockwise, which is what we expected, right? Because most of the force comes from that torque at position 1. Even though it's closer, its significantly greater size of force would mean that the overall torque is counterclockwise. Unfortunately, this torque wrench breaks and you only have a measly regular wrench. But you want to tighten the lug nuts on your car to exactly 90 Newton meters, right? It's required by the manufacturer and you want to be safe. The wrench is 30 centimeters long. What is a possible force and distance combination to achieve this torque? So, wrench is 30 centimeters long, or let's just use SI units because we can, 0.3 meters long, and you want to achieve a torque of exactly 90 Newton meters. So you have a few things to decide. You need to decide where you will position your hand along the wrench and how much force you will apply. Now, if you've ever, tightened something or tried to loosen something, you'll know that leveraging it by having a greater moment arm, in other words, this length, by applying the force as far away as possible, will make it easier to rotate. So a good first step would be to set the distance of the moment arm to be 0.3 meters. Now we know that the torque is force times distance, where the torque needs to be equal to 90. We need to work out the force, and we know the distance will be 0.3. So solving for force, 90 divided by 0.3 gives 300 newtons. So a possible answer would be to apply a force of 300 newtons at a distance of 0.3 meters from the pivot point. That's only one possible answer. You could also apply the force in the middle, right? You could set the distance to be 15 centimeters, 0.15 meters, and by the same logic, set the torque to 90 and solve for force. And so actually, if we halved the distance, we would need to double the force, right? Which is why it appears to be easier the further along the wrench you apply that force. So a bit of an open question. Any valid combination works. The only one that doesn't work is if your distance is 0, because then you will not be generating a torque. Right? If you're curious, try set your distance as close as possible to 0 and see what happens to the force required. Alright, part 2. You also are feeling generous and tighten the lug nuts on your friend's car because they forgot to. It happens. However, their car's a bit older and it requires a greater torque. Or maybe it's newer. Not too sure. Anyway, you need to achieve a greater torque. Describe how you can achieve this with the same wrench. So similar to this question, we have a 30 centimeter wrench, 0.3 meters. You want a torque greater than 90 meters. So to achieve the maximum torque, you'll want the distance to be 0.3 meters. However, we would need the force to be greater than 300 newtons for the torque to also have a greater magnitude. So we could say, let's just write out the equation. For maximum torque, D should equal 0.3 meters. And And why is it 0.3 meters? Well, we're restricted by the size of the wrench, as this is the maximum. No. As this is the full length of the wrench. Now, to increase torque further, a force greater than, what was it, 300 newtons must be applied. And why is this the case? Because torque is proportional to force. Right, as force increases, torque also increases at the same rate. And since we've fixed the distance to 0.3 meters, right, which was the maximum distance we could choose due to the wrench size, the only way to increase torque further is to increase the force. Now, you might have been creative and said you could stick a pipe on the end of the wrench to increase the distance, and that is actually what a lot of people do, right? So, life pro tip, if your wrench isn't quite strong enough to loosen or tighten a nut to a certain requirement, find a bit of like steel pipe, slot it over the wrench, and then you've increased the maximum possible distance, meaning you can apply a greater torque. And so that does it for this question. Go check your lug nuts, I guess. See ya.